to evaluate the determinants of matrices. Then we shall find the determinant of 2 by 2 matrices on my left. This video will have some more videos to read in the video series, whereby we shall deal with part 2, where we shall deal with the determinants of 3 by 3 and 4 by 4 matrices. Please, before you continue with this video, it is highly recommended that you view the videos in the playlist on matrices. Matrices and determinants is a playlist on my website. So it is recommended that you view the previous videos on that playlist prior to viewing this one. So what do we know about determinant? Let's say that the determinant of a matrix, say matrix A, is the first thing we want to know about determinant is that it is denoted, you can say denoted or represented or designated, denoted by det A. We write it as det A, the short form for determinant. Or this, you can say that this looks like an absolute value of A, but in some textbooks you will see it as a meaning determinant of A. Then number 2, it can be positive, 0, or negative value. The determinant can be a positive value or a 0 value or negative value. Number 3, it is used to determine. Whether a matrix has an inverse or not. It is used to determine whether a matrix has an inverse or not. Okay. Then number 4, we see the applications of determinant in a solution of linear systems. When we discussed linear systems, solution of linear systems, we talked about Cramer's rule. Cramer's rule uses determinants to find the solution of linear systems. And we also use it to, of course, find the inverse of a matrix if it exists. We also use it to do that. It's used in solve solution of linear systems. It's used to find the solution of linear systems. Used to find the solution of linear systems. It could be 2 by 2 linear systems, it could be 3 by 3 linear systems, it could be 4 by 4 linear systems, okay? Inverse of matrices, and of course, with the inverse of matrices, you talk about cryptography or cryptology, yeah, among others. So that is what we can say about determinant. Now we should note this, that a determinant of a matrix only exists for square matrices. Okay, matrices that are not square matrices do not have determinants. You know what I mean by square matrices. We talked about it in previous videos. Note that determinants are only for square matrices. Square matrices. In other words, you can, and if you want to call this number 5, that's fine. The determinant of the matrix is just for square matrices. For matrices that are not square matrices, they do not have determinants. Alright, so the next thing we will do now is we have an idea of what a determinant is. The next thing we do now is to discuss how do we find determinant of a square matrix. Okay? So how do we go about finding determinants of square matrices? So before we discuss determinants, we have to look at the formula for finding determinants. Formula for finding determinant of a matrix. Okay, and if it is, let's say, if we have a matrix, a 2 by 2 of a square matrix, let's make sure we put square matrix of a square matrix, because the determinant exists only for square matrices. So let's say we have a 2 by 2 matrix, square matrix. Okay, let's say we have something that matrix A is A11, A12, A21, A22. Okay, this is for 2 by 2 square matrix. So if we have a 2 by 2 square matrix with these elements, then get A, determinant A will be, of course, it will be A11 times C11 plus A12 times C12. Or you can have it as A21 times C21 plus A22 times C22. Now, the question you will ask me now is, what is C? What is C? C is the cofactors. We will come to that. Okay? We will come to that in a moment. If it is a 3 by 3 matrix, assuming a matrix A is A11, A12, A13, A21, A22, A23, A31, A32, A33. Then the determinant of this matrix, will be determinant A will be A11 times C11 plus A12 times C12 plus A13 times C13. It could be any of these. If you're using the first row, you know, just like in 2 by 2 matrix, if you're using the first row, then you use this. If you're using the second row, you use this. It does not matter. Or, if you're using the second row, it will be A21 times C21 plus A22 times C22 plus A23 times C23. Or it could be A31 times C31 plus A32 times C32 plus A33 times C33. So the same thing applies if you have 4 by 4 matrix, square matrix. It could be A11 C11 plus A12 C12 plus A13 C13 plus A14 C14, or A21 C21 plus A22 C22 plus A23 C23 plus A24 C24, or A31 C31 plus A32 C32 plus A33 C33 plus A34 C34, or A41 C41 plus A42 C42, or A43 C43, or A44 C44. Okay, so that is how we find the determinant of square matrices. 4 by 4, 5 by 5, 6 by 6, 7 by 7, 8 by 8. That is how we find it. Alright, so now we know the element. A11, A21, we already know the element of the matrix. But we don't know the cofactor. So that brings us now to the concept of cofactors. So, cofactors. Now, in the concept of cofactors, we want to, before we talk about cofactors, we have to talk about what we call minors. First of all, cofactor of a matrix, okay, is usually denoted as cofactor of a matrix. Number one are sign minus. Okay. that is minus with signs. Okay, now this is not minor like somebody who is less than 18, no, or less than 19. Well, generally less than 19 years is a minor. So this is not the kind of minor we're talking about. No, we will look at what we mean by the minor. Number two, denoted as C, denoted as uppercase C, denoted by uppercase C. So, like when we have C11, for instance, C11, this means cofactor of A11. Okay, denoted by C, and then with subscripts. If we have C32, this means the cofactor of A32. Okay? So now, the next thing we have to do now is what we call minors, because we have talked about minors. So that is the next thing we will talk about now. And then after we discuss minors, we will still come back to cofactors. And then we will now find the determinant and then solve this 2 by 2 determinant of 2 by 2 matrices here. So, but just know that determinant has just this formula to use to solve it. Okay, I'm trying to teach you from the basics, from the foundation of this. I do not just want to give you a formula like that and go. No, I want to tell you how and why. Okay, so let's look at minors. If we look at minors of a matrix, minors of matrix elements, okay? Minors of matrix elements. Okay, let's say before I give the definition of this, I would want to show you first of all what I mean. Say you have a matrix. Say you have a matrix A. Let's look at a 2 by 2 matrix, okay? A11, A12, A21, A22. Okay, so now if we want to find minor, minors are denoted, you know, by uppercase letters with subscripts. Remember, in the first video of matrices, we said that the elements of a matrix are denoted by small letters, lowercase letters with subscripts. Okay, and these subscripts means the position in the row and column. Okay, like element in the first row, first column, element in the first row, second column, and the rest of them. Okay, now the element is denoted by a lowercase letter with subscripts, but the minor is denoted by uppercase letter with subscript. Okay, let's say minus number 1 are denoted by uppercase letters with subscripts. Okay, that's the first thing we should know about minors. Now, the next thing we should know about minors is this. If we want to find the minor of an element, what we need to do is this. We will delete the row that the element is in and the column that the element is in. And whatever is remaining is the minor, okay, of that element. For instance, and I'm going to use a colored chart here. If you want to find minor of A11, let's say we want to find minor of A11. Okay, minor of this is what we want to find using a yellow chart here. So this will be uppercase with subscript. Okay, uppercase A with subscript. So how do we find this minor? We delete the row and column. Okay, so I'm going to use a red. Red means delete. You delete whatever this is in the first row and first column, we delete it. First row, first column. So once we delete it, whatever is remaining is the minor, A22. So the minor of the element A11 is A22, the element that is in the second row and second column. Now, the minor of A12 is what? Uppercase A, then 12. Right? That means we will delete the element. This is A12. Let me use this, okay, for the second column. So this means A12, we delete the row, the column, the vertical, and the row horizontal that the element is in. So we delete this, and we also delete this. Okay, and if you do that, what will be remaining will be A21. Okay, now the minor of A21 will be what now? Uppercase A21, right? And that will be you delete this. You know, when you can when I was doing this, you know, so many years ago, you know, when I do this, like you do this, it's as if you're praying, you know. But you delete it, this, and when you do that, you find out that this is A12. Okay. And then the minor of A22. Okay, A22. And it doesn't matter if you pray when you're doing this, so that you do not make a mistake. It does not matter if you pray when you are doing this. so that you do not make a mistake. Okay, so minus A22 will be what? A11. A11. So you see how we find the minus, right? Now, these are the minus. So a minor of an element is found first by a minor of an element is the remnant that is found after deleting the rows and columns of that element. Okay? A minor of an element is kind of the remnant found after deleting the rows and columns of that element. Now, this is the same principle we shall use for 3 by 3 matrix, and you will see, you will see how we do it. For 3 by 3, for 4 by 4, 5 by 5, it is the same principle. All right, so we have found the minus. The next thing is to find the cofactors. Like I said, cofactors are signed minus. Okay, so why don't I just use here cofactors, uppercase C, and like I said, they are signed minus, minus with signs. Now, how do we assign signs to minus? Okay, the rule, we have a rule. Rule is if the sum of the subscripts is even, then assign a positive sign. If the sum of the subscripts is odd, assign a negative sign. If the sum of the subscripts is even, if then statement, if then, then assign a positive sign. If you're a computer programmer, you know what I mean by if then. Then you can just write else. You don't need to write else if this time around. You don't need to write else if. Else, assign a negative sign. That's else, meaning that if the sum of the subscripts is odd, then assign a negative sign. Or you can just type end if, and then you begin another if again. Okay? Then another one, I'll just do it with asterisk. Then if the sum of the subscripts, is odd, this is for even, assign a positive sign. For odd, then if then, assign a negative sign. Then assign a negative sign. And end if you are typing this in the program. Okay, now let's look at this. Let's see what they're talking about. This will be, what we mean here is this. We mean that C11 will be, because 1 plus 1 is 2, 1 plus 1 is 2, so this is going to be plus A11. And that will now be plus what? Small a22. Remember, A11 is element A22. Then C12, 1 plus 2 is odd. 1 plus 2 is 3, which is an odd number. Okay, so it's going to be negative A12, and that will give you negative A21. Okay, that will give you negative A21. Then C21, the cofactor of A21 will be 2 plus 1 is 3, which is negative. So this will be negative A21. And that will be negative A12. Negative A12. And then C22 2 plus 2 is 4, and that is even. So this will be plus a to 2, which is positive a11. So you see this is what we need here. This is what we need here. Now, some textbooks now make this seem easier, you know. With this, of course, you kind of know that if you were to put this like just the cofactor form, just the signs, just the signs, if you were to put it in the signs form, okay, you will notice that this will be plus, this will be minus, this will be minus, and this will be plus. You notice it like this, okay? Now, let us now go ahead and find the determinant of what we are talking about. So, if we now find the determinant, say that A is A11, A12, A21, A22. So remember with the formula I gave you earlier, determinant of A, this is still, I can write that A, or I write this, determinant of A. Okay? Now these are equal bars, please. They are equal bars. So that will be A11, right, times C11. My C11 is what? Plus A22. So this will be A22. You see that now? A11 times A22. Then plus A12 times, then my C, let me just write this formula again so that you will kind of follow me along. Or you can read, you can look in your book that you wrote it. We see that this is A11 times C11 plus A12 times C12. Or, okay, or we will still note the or the determinant of A will be A21 times C21 plus A22 times C22. Okay, so now let's see what we got now. So this will be A11 times C11 is A22 here, A22, right? Then plus A12 times C12 is what? Negative A21. So you see this now. This is what we will have here as the determinant. Or we can still have A21 times C21 is what? Negative A12 plus A22 times C22 is what? Plus A11. So this, or this. So this is what we are going to have. And now look at this very well. It says the same thing. It's just like this is switching sides, you know. It's like this is switching sides. If we finish this up, this is what we're gonna get. Okay, so we now have the determinant of A, or that A will be A11, A22 minus A12, A21. Because when you do times, plus minus, because this is plus minus. You understand what I'm saying? This will be plus minus, and then later on, plus minus is minus. So this will be minus. I can kind of write it again. Determinant A11, A22 minus A12, A21. So this is kind of what you have. Okay? Or determinant, this is what? Negative A21, A12 plus A22, A11. So you see, this is kind of saying the same thing. We are saying the same thing here. It's just like saying 5 minus 3 and minus 3 plus 5. You know, just like saying 5 minus 3 and saying minus 3 plus 5. It's the same thing. Okay? It's still the same thing. So now the textbook will now simplify it for you and now tell you that what you could easily do is just by multiplying this diagonal, because either way is gonna be the same thing though. Okay, so just multiply the diagonal, A11 times A22 minus multiply this diagonal. Okay, so this like a cross, this times this, A11 times A22 minus A21 times A12, or minus A12 times A21. It does not matter. It's the same thing. 2 times 4 is 4 times 2. Okay, so it's kind of now, if you read it in textbooks and they go straight to telling you that this is the determinant of a 2 by 2 matrix, this is how it was found, what I just explained. Now, why did I take all this time to explain this? This will save us time when we do the next video of 3 by 3 and 4 by 4 matrix. Okay, it will save us much time. So, but for 2 by 2 matrix, you can go away with this by just multiplying the diagonal, this times this minus this times this. You can get away with it. That is fine. You can. But that is not the same way you do 3 by 3 matrix. That's by the diagonals. No, you don't do that like that. You still follow the same procedure, just like I did for 2 by 2 matrix. Alright, so we can go ahead and solve some questions. I have been talking. Now let's solve some questions right away. So if you see the signs I did, it will kind of tell you plus, minus, minus, plus. Okay. This is when we looked at this sign, plus, minus, minus, plus. This is plus A11. This is all. If you're choosing the first row, if you're using the first row, then you know that this is plus. Plus, that's A11 times plus A22, then plus A12 times minus A21. You can either use any of the rows. So if you're using the first row, this is the way it will go. Or if you're using the second row, the negative comes here. You see this negative here. If you're using the second row. But if you're using the first row, you see this negative. Okay. Alright, now let's go ahead and solve some problems right away. So we will use this easier form since we found out that either way, if we just multiply the diagonals and subtract, we will get it. So we have to use that way, okay? But if you want to use the procedure that I use, that's fine. Does not matter. You know what? For question 1, I'm going to use I will solve the determinant from the definition, right? And then I use that of the diagonal. And then for the rest of the problems, I use the diagonal because it saves time. Okay, number 1, find the determinant if A is 5, 2, 3, 1. Okay, by row 5, 2. By column 5, 2, 3, 1. By row will be 5, 3, 2, 1. Now determinant A, that's A. If we want to do this, okay, if we want to use this will be plus, minus, minus, plus. So what we can do is or if you want me to kind of break it down very well, I have that A11 is 5, okay, C11 will be plus, because this is 1 plus 1, 2. So this will be, bam, bam, when you cross this out, bam, bam, you have 1. So C11 is 1. Okay? Then we look at, remember that A will be A11, C11 plus A12, C12. Or you can use any one of them. You can use either row. You can use the first row or the second row. Then A12 will be what? A12 will be 3. And then C12 will be, this 1 plus 2 is minus. Okay, this gives you the signs of the cofactors. This gives you the signs of the cofactors. So minus, I come to 1, 2, minus 2, minus 2. Okay, so my net A will be A115 times 1 plus a 1, 2, 3 times minus 2. And that will give me 5 plus negative 6. 5 minus 6, and that is minus 1. This is following it from the definition. Yeah. You can also use A21, C21. If we do that, what do we have? If we use determinant A to be A21, C21 plus A22, C22. Okay, so we have that A21 is what? 2. C21, 2 plus 1 is 3. Minus, okay, this is going to give me minus. Now when I do bam, bam, that should be minus 3. Then A22 is 1. And then C22 is plus, and I do bam, bam, plus 5. Plus 5. So this will now be A21 is 2 times negative 3 plus 1 times 5. And that will give you negative 6 plus 5, and that will give you negative 1. So 5 minus 6, negative 6 plus 5 is still the same as negative 1. Now, this is following it from the definition. What if I do not want to follow it from the definition? What if I want the easy way out? Just diagonal right away. So that will be just 5 times 1. If I just do it because it's a 2 by 2 matrix to save time, it will just be what? It will be diagonal 5 times 1 minus 2 times 3. And that is 5 minus 6, which is minus 1. Okay, saves you time than writing out all these, writing all these out. But that is actually doing it from the definition. That is doing it from the definition. And when we will do 3 by 3 matrix, we are going to do it from the definition. We are not going to run away from it. Okay, so we can say that A is just 5 times 1 minus 2 times 3. So 5 minus 6 minus 1. Easy, math? Easy, right? Okay. Number 2, if B is equal to 7, negative 2, 12, 5, what is the determinant of B? So this will be 7 times 5, right? Minus 2 times 12. Okay? 7 times 5 minus 2 times 12, which is 35, minus 24, which is 35 plus 24, which is 59. Okay? 35 plus 24, which is 59. Alright, the next one, number 3. Number 3, we have that C, matrix C is 1/4, 10, 2/5, 20. Okay, so the determinant of C, that C will be 1/4 times 20, 1/4 times 20, okay, minus 10 times 2/5. So this will be what? 5, because 4 divided 4 is 1, 4 divided 20 is 5. Multiplication of fractions. Watch my video, Minus 5 divided 5, 1, 5 divided 10, 2. 2 times 2, 4. And this will be 1. 5 minus 4, 1. Yeah. Unimodular matrix. Unimodular matrix. If the determinant is 1, it's a unimodular matrix. Okay, 5 minus 4, 1. Let's make sure we got it right. Okay. The next one, number 4. Number 4, we have that determinant, the matrix D is negative 5, 5 by column 0, 0. So determinant D that D will be negative 5 times 0 minus 5 times 0, which is 0 minus 0, which is 0. And that reminds me now, if the determinant of a matrix is 0, that means the matrix is a singular matrix. Singular matrix and non-singular matrices. I'm going to write the definition right now. You know, when we did the first video on matrices, we said that we will keep on learning the types of matrices. I told you then that you had a lot more, and as we go on, we will learn more. So if the determinant, we talk about singular matrices. Singular matrices. So keep adding to your collection. Keep adding to your collection. So our matrices, singular matrix is a matrix whose determinant is 0. Singular matrix is a matrix whose determinant is 0. So keep on adding from that collection you have. And we talk about a non-singular matrix. Non-singular matrix. Non-singular, you should have a space after non-singular matrix is a matrix whose determinant is not 0. Whose determinant is not 0. So that is what we mean by singular and non-singular matrix. Okay? Now let's go ahead and finish this, please, so that we have a question 5. Matrix E is equal to, by column, this is K, negative 4, and negative 3K. Don't be mad at the algebra because you now see variables. It is still the same process that we will use to solve it. So the determinant of E will be K times K, okay, minus 4 times minus 3. So be careful of this minus. Whether you say minus or whether you say negative, it is the same thing. I have said it so many times. If you view my videos on integer operations, whether you say minus or whether you say negative or whether you say subtract, it is the same thing. So this will give you K squared minus that minus 4 times. Now you see, I like doing this. I like having this minus here first. Dealing with these two. Deal with these guys first. How about you deal with these guys first? So you don't get confused, because some folks will come here immediately and write plus 4. Don't do that. Okay? Deal with these guys first before just do PEMDAS. PEMDAS. Okay? PEMDAS. Okay? Before you subtract, multiply first before you subtract. PEMDAS. Students usually get confused. They come immediately and do minus and do plus. Plus 4 times negative 3 and then do minus 12. You don't know. I don't want you to go by that. No. Okay? Just deal with these two guys first. Get this guy, K times K squared. Get it? Breathe in. Then take a break. Write the minus down, then get minus 4 times minus 3, get it, and then you now subtract. Use PEMDAS. You multiply first before you subtract. So minus 4 times minus 3 is 12. And this becomes your determinant. A squared minus 12. Okay? Now, this is not difference of two squares because 12 is not a perfect square. So you just leave your answer like that. But deal with the guys first before you now subtract. That is what I'm saying. Deal with the two guys first. That is, do multiplication first before you do the subtraction. Okay? Remember, it is this times this minus this times this. Some textbooks will have it as A, B, C, D, right? Now, some textbooks will write it this way. They will write it this way, that if it is A, B, C, D, so you have first A, B, the determinant, okay? Determinant, assuming this was A to be this, determinant will be AB, then minus BC. Okay, but deal with this guy first. Deal with this guy first. Deal with this guy first before you subtract. I mean, that is where some textbooks will have it. And then some people memorize. I don't like memorizing. Just know that it will work that way. Or know how to solve it from the definition. And then you understand it. No need for memorization. Understanding versus memorization is you have to understand, not memorize. Okay? Now 6. F, matrix F is exponential function E, 2x, 5, and then negative EX. Okay, so determinant of F will be EX times negative EX. Some folks do mental math and they try to do this and they make mistake. Mr. C will not advise you to do so. Now minus, deal with this guy first. Then 5 times E2x. So what's this gonna be? This will be, now this is like saying negative 1. That is what it is, like saying negative 1. Okay? If I have to break this down, this is like saying e to the x times e to the x times negative 1. That is what it means. Minus 5 times e to the 2x. So e to the x times e to the x. Remember, law of exponents. So this is, you bring down the base, they have the same base, add up the exponent, x plus x, then times negative 1 minus 5e to the 2x. So this will be e to the 2x times negative 1 minus 5e to the 2x. Right? So what would this now be? Negative 1 e to the 2x. Okay? Negative 1 e to the 2x. So from here, this will be negative e to the 2x minus 5e to the 2x. See that? Because this is like saying negative 1, which is still, I don't want to put 1 here, but minus e to the 2x minus 5e to the 2x. Minus 1 minus 5 is minus 6 e to the 2x. And this becomes the determinant of f, which is f. Okay, the last one, the last but not the least, number 7, matrix G is by row. This is ln x, then 2 and 5. You remember your ln. Your ln is the logarithm to base e. Okay, that's your natural logarithm. View my video on logarithmic